All right, couple things. Let's see. The plan for today, just go over some of the things coming up in the syllabus. Give you a chance to ask questions about the in-class assignment that you had Wednesday and that you turned in Friday. I posted a video on Saturday that had the answers to that. And I noticed not everyone in the class has looked at that. Last time I looked this morning, 12 people had watched that video. So I definitely encourage you to watch that video that I posted. It does have the answers to the problems that we did. Started Wednesday, you turned in Friday. I'll finish up talking about the research design, stats, method stuff that we started last week. Probably get a start on chapter 1 today. Let's see. I wanted to give you, oh, yeah, I wanted to say a couple things about these assignments coming up. So, next week, Monday, you will have your first quiz. So, today, you just had this quiz was due from textbook chapter 1. You have a quiz due Wednesday of this week for chapter 2. A week from today, the start of class, you will have your first Master and Emissary Blackboard quiz, and then there'll be chapter 3. So this afternoon, I will have the master. So my goal is to have these posted 1 week before they're due. So this one will be posted. The Master and his Emissary quiz will be posted this afternoon. I might even get to the chapter 3 one today. But if not, I will definitely be able to post the chapter 3 one by Wednesday. I also wanted to say something else about, before I forget, the participation aspect of this class. So last week, this is something different that I've done in the class where I'm going to give people up to 4 points extra credit, I believe is what I said in the syllabus, for asking questions or making helpful comments in class. And I realized last week that if people are saying them verbally in Zoom, that I can't actually see who is saying the questions or the comments. And so moving forward, I would like everyone, if you have questions or comments, just to go ahead and use the chat because I can see your name right there, and then I can write it down and keep records for participation purposes. So I'll just repeat that again. Please don't just verbalize them. Like if you can, I want you to write down them in chat, and then if you want to verbalize it right after you write it down, that's fine. But I definitely want a record of all the questions that were asked there on the chat so that I can very easily see who is asking the questions. And I do see a chat question right now. Will next Monday's quiz cover Master and his Emissary chapters 1 through 3 or only chapter 3? It's just the introduction. So let's look here in the syllabus. It says Master and his Emissary introduction. So it's just the introduction. So it's a pretty short reading, if I recall, only like 20 pages or something like that. So the Master and his Emissary reading for next Monday is just the introduction. Let's see what these other chats are looking at. Do we have 2 quizzes over Master and his Emissary chapter 3? No, we do not. That is not. I'm trying to understand why that's being asked. No, so chapter 3. Okay, I see. I think I see why you're asking that. Chapter 3 right here. This is the textbook chapter 3, and what this means right here is that I'll be lecturing about textbook chapter 3 on this day. Your quiz over chapter 3 from the textbook though will not actually be till Wednesday of that week. So February 17th is when your Blackboard quiz over the textbook chapter 3 will be. The way the Master as Emissary, I don't call it chapter 1, chapter 2, chapter 3 for the Master as Emissary. I always just call it the names of those chapters. The Master and his Emissary introduction, that's like chapter 1. The Master and his Emissary Symmetry in the Brain, that's chapter 2. Yes. So it's yes. So the bolded entries are always assignments that are due that day. Everything that you see that is darkened means, and I did mention this last week, I believe, during when I was going over the syllabus, all of the bold parts are things that you have grades, assignments that are due that will be graded that day. No, yeah, it's not a problem. Okay, so yeah, if you have more quizzes about the assignment, yeah, it's not a bad thing to repeat. I want to make sure everyone's on the same page here. If you do have more questions about this, yeah, the non-bold stuff on the syllabus, just the stuff that I'm planning on going over that day. As far as lecture, and then the bold stuff is the stuff that you have quizzes on. So, yes, thank you for asking those questions on the chat. I have a record of everything, and so I'll be able to kind of look this over at the end of class and write down everyone's contribution there. So that is helpful. Okay, so that is the syllabus. These assignments coming up. If you do have more questions, I'm happy to answer. Just send me an email or send me another chat here later during class. Okay, so let's see. Now let's go to the stuff that we were doing last time. These 6 scenario problems. So I did once again post the answers to these. A 15-minute video on YouTube. Then I posted the link and on Blackboard. So take a look at that if you haven't. I did want to give people the opportunity to ask questions about that. Does anyone have any questions about any of the answers to these problems, or anything about any of these problems in general that they want to ask about? We can go over parts of some of these problems here. Yes, someone asked, do you post slides on Blackboard so we can review them later if we want? Yeah, all the slides are there right now. This is there right now, and chapter 1 slides are there coming up, or our chapter 1 slides that I'll be talking about later today are also there. Yeah. Okay, so it doesn't seem like anyone's asking questions about the scenario problems yet. Yes, someone asked, did one person have to turn in the problems if which worked as a group? Yes, only one person has to turn them in. If you do it as a group, you can work in groups. So up to 4, you just have to put all of your names. That is mentioned in the syllabus. So check out the syllabus. It does mention how you're supposed to turn things in on the syllabus if you're working as a group. No problem. You're welcome. Okay, so if no one has questions about these, I do believe the video I posted was pretty self-explanatory for these 6 scenario problems. And these should be kind of review type of things. There will be 1 or 2 questions on test 1 kind of this nature. So if you did struggle with these 6 scenario problems, that's not a bad idea to set up a meeting with me and we can work on them one-on-one. Also, definitely check out the video with the answers for that. It should be helpful. So I wanted to kind of continue on along, just kind of going a little bit more in detail about some of these different research designs. We've talked about the different hypothesis tests that are used to compare means. We talked about t-tests. We talked about one-way ANOVA. We talked about factorial ANOVA. Those are kind of the main categories of hypothesis tests. The regular, there's the weird t-test, the one sample t-test, which we're actually not going to talk about too much in this class. The regular t-tests, that is the between subjects t-test, within subjects t-test, they compare means of 2 conditions when you have just one factor with 2 conditions. The between subjects t-test, it's a between subjects factor. The within subjects t-test, it's a within subjects factor, comparing the means of those 2 conditions. In a one-way ANOVA, that one-way part, I'll remind you, means we have one factor. And you're comparing the means of the different conditions of that one factor. A factorial ANOVA means that you have at least 2 factors. And so here is an example of a one-way ANOVA that was used in an actual study. So my examples that I'm going to provide today are still more on the psychology side. I do have one at the end of this chapter, which is cognitive neuroscience. But the cognitive neuroscience examples are just more complicated, and I don't want to overload you with cognitive neuroscience examples just yet. I kind of want to give you examples, getting your brain refreshed about this stuff, that are not super challenging. Cognitive neuroscience examples are just a little bit more challenging usually. So here's an example of a study where a one-way ANOVA was used. So this is the Mozart effect, which is a real effect. This study was actually published in Nature, which is a highly ranked journal, has a very large impact factor. It's a highly cited journal, including this article, which has been cited hundreds and hundreds of times. So this is the Mozart effect, in which there are these 3 different conditions. There's a music condition, and here people listen to Mozart music. And then there's a relaxation condition in which they're listening to some type of relaxation tape, or someone telling, like, verbally saying how to relax. You're listening to someone giving you trying to get you to relax by what they're saying. So the difference here, this is music, this is someone talking to you, and then this is silence, where you're just sitting there doing nothing. And then what they have the participants do is they have them in each of these 3 conditions. And then they had these people perform what they call it here was a SAS, standard age scores, but that's just kind of a fancy way of saying it was a spatial task. And a spatial task involves you seeing something on like a computer screen, and you have to like mentally rotate it in your head, and then you have to perform some type of task based on the mental rotation in your head. It's just a spatial task where you have to kind of see the different spatial orientations of something that appears on a computer screen. And what they wanted to see is there a difference in performance on the spatial task, that SAS, the standard age scores for the spatial task, depending on each of these three conditions, whether you just listen to Mozart music, whether you're in the relaxation condition, or whether you're just sitting there in silence. You do each of these three things, then you take the spatial task, and they wanted to see, did these three things influence your performance on the spatial task? And the Mozart effect is the fact that in this study, and it has been replicated several times, people tend to do better on the spatial task after they listen to Mozart compared to these other conditions. You can see here, the bar is relatively taller, meaning they are around 58% accuracy here compared to about 55 and 54% accuracy here. And this was a significant difference. And let's see if we can find it. It says a one factor, and they call that factor listening condition. These are the different listening conditions right here, the three different things you could listen to. Repeated measures analysis of variance. So remember, repeated measures means within subjects. And so they actually had these people came into the laboratory on 3 different days. On day one, a person comes in, they are in the music condition. Then on day two, the person comes in again, and they're in the relaxation condition. On day three, they come in and they're just in the silence condition. Each of those 3 days, the person performs a spatial task. And so it's within subjects because each participant was in all three of these conditions. And each day they performed a spatial task. The repeated measures now one way, it's a one factor or one way analysis of variance because we just have that one factor, which they called listening condition, composed of these three levels, three conditions. Revealed that subjects performed better on the spatial task after listening to Mozart than after listening to either the relaxation tape or after listening to nothing, that is, after silence. And so there's the results of the one-way ANOVA. The one-way ANOVA in this case is comparing these three means simultaneously. All three of these means are being compared. So can someone tell me, why would a t-test be an inappropriate statistical analysis for this research design? Why would a t-test not work here? Please use the chat to answer this. Why would a t-test? Yep, and very quickly we got the answer that there are more than 2 levels. Someone else said because there are 3 conditions. Both of those are exactly right. T-tests, the most amount of levels you can use, the most amount of conditions you can have are just the 2. Here we have 3 conditions, so a t-test won't work. You have to use the ANOVA to compare the means in this situation. This is a one-way ANOVA because we just have that one factor. Can someone tell me, what is the dependent variable in this study? What is the dependent variable in this study? Can anyone tell me that using the chat? Anyone tell me what yep, performance on the spatial task, abstract spatial reasoning, SAS, those are performance on the spatial task. I get like a million. Yeah, there's a little small delay, but then I got like 6 or 7 correct answers right in a row. So you guys are all doing well on that. Dependent variable, just performance on that spatial task. Whereas the factor, you could call this an independent variable, or the factor is the listening condition. So I think we've talked enough about this example. One-way repeated measures ANOVA. So that's a one-way design because we just had the one factor. It was kind of a complicated example because it was a one factor that had 3 levels instead of just 2. But now we're definitely going to get even more complicated. One-way designs are nice, but they're actually kind of rare. So I gave that example. It's kind of hard finding published studies that only have one factor ANOVAs. Those are kind of rare. Much more common in psychology and especially in cognitive neuroscience are factorial designs, which are just more common and they're more complex and more powerful. Just usually you get more interesting results from factorial designs than one-way designs. And so we definitely want to talk some about factorial designs today. So factorial design, remember this term, one way. When I talk about one way, that just means one factor. Factorial means we have 2 or more factors. So I'm going to talk about this thing called factorial nomenclature, which is what this is. You should have been exposed to this a little bit in your research methods class. But I just want to make sure that it's not particularly difficult, but it's very common when you're reading it in psychology or cognitive neuroscience papers. You have these numbers. So here's an example right here. These are just factors in a made up study. All of these studies right here are completely made up. And so here would be a factorial design. We have two factors, amount of coffee, and we'll say the levels are people either drank 0 cup, 1 cup, or 2 cups of coffee. And then type of diagnosis, or you could say type of participant, type of person. And then the two levels of this factor would be people with schizophrenia and people that don't have schizophrenia. And so we're interested in this made up problem. How does drinking coffee influence people? And we'll say that the dependent variable is the same one we were talking about last week. Short-term memory was the example I used last week. How does drinking coffee influence people's short-term memory? And does drinking coffee influence people's short-term memory differently depending on whether they have schizophrenia or depending on whether they don't have schizophrenia? This is a pretty common example of the type of study that would use a factorial design. And so I said here, it's a 3x2 factorial design. This is the factorial nomenclature, which nomenclature basically just means like name, a way of naming things. So 3x2 here, and it says down here, the amount of numbers in the factorial nomenclature represent the amount of factors. So if you see we have factor 1, factor 2, and you can see we have one number here and another number here. The amount of numbers here, this X is pronounced by, 3x2. The amount of numbers here are the amount of factors. This is factor 1, this is factor 2. The value of each number represents the amount of levels. So if you look, amount of coffee, 1, 2, 3 levels. So we have the number 3 there. Type of diagnosis, 1, 2. We have 2 levels. So we have the number 2 here. So that's a two-factor or a two-way design. And then here's a three-way design. So these get pretty complicated. Two-way designs are pretty complicated. Three-way designs definitely happen too. Yeah, they happen a good amount. I would say two-way designs probably are published slightly more often than three-way designs. Three-way designs are definitely more complicated, but they can be very, very powerful as well. So 3x2x2, we can see here that we have three factors, 1, 2, 3. Let's kind of look at what each factor is. The first one, once again, is just amount of coffee, whether people drink 0, 1, or 2 cups of coffee. Type of diagnosis, same one from up above, whether people have schizophrenia or they don't have schizophrenia. And then finally, I added this third factor here, biological sex, whether people are male or female. So this is 3x2x2 because we have 1, 2, 3 factors. This number 3 comes from the fact that we have 3 cups of coffee here, 3 levels. That is 3 conditions. This number 2 comes from the fact that we have 2 conditions here, 2 levels, 2. And this number 2 right here comes from the fact that there are 2 levels here in the factor biological sex, male or female, the number 2 right there. So that's factorial nomenclature. And then moving on here, these are also terms that you probably dealt with a little bit in research methods, probably not as much in your statistics class, but if you took research methods, you have these terms. And I like to go over them because these terms are a little bit difficult for students. I remember I didn't really get a hang of these terms like really solidly until I performed my master's thesis in graduate school, where I had to actually perform these analysis for my thesis. I had a factorial design. And then once I actually had to once I was immersed in the statistical analysis, then it became very clear, very easy to differentiate what a main effect versus an interaction is. But I wanted to make sure that we cover it here so that you can understand the difference between these. And so I'll give you kind of these definitions here, but they're just wordy. And so I will give you some examples that will help, that will help illustrate more concrete examples that will help illustrate what these terms main effect and interaction mean. So these are terms that apply only to factorial designs. Remember, factorial means we have 2 factors or more, at least 2 factors in a design. So for a main effect, there is one main effect calculated in your statistical analysis for each factor in your design. So if you have a 2-way design, that means you have 2 factors. That means you'd have main effect for that first factor and a main effect for the second factor. If you have a three-way design, meaning you have three factors, that means that your statistical analysis is going to output three different main effects. And each one of those could be significant or not significant. Once again, I'll give you some examples, which I think make this a little bit more concrete. The means which are compared for a main effect are called marginal means, and we will actually calculate some marginal means here in a second. And if the main effect is significant, this indicates there's a difference among the means for just that factor. And the important thing about the main effect is that you're looking at the means of one factor when you're actually ignoring the means of the other factors. So once again, these are very wordy definitions right now, and they're not going to really sink in, I don't think, until you have examples, which I will provide. An interaction right here. This is the term which is probably, this is the part that the concept which gives students the most trouble. The interaction, it looks at the means of many conditions, or usually in a two-factor design, the interaction is looking at the means of all of the different conditions of the experiment. And if it is significant, and this is the most wordy definition there is, it indicates there's a difference among condition means for one factor, and it is influenced by the levels of the other factor. So this is wordy. Every time I read this, I've been teaching this for a long time. Every time I read this, it's like, yeah, I think I get it. But really, you just need the concrete example, and that helps kind of explain or helps this sink in. We got a question here. Says, so the question is, so the overall interaction of the study. That's a little bit too vague of a question to answer, I believe. So I'm just going to show a specific example, a concrete example. And if you still want to ask a question, you here in a second, maybe, yeah, we can expand upon that once I give the concrete example. I will say an important thing about interactions is that they require talking about both factors or more than one factor. When you're talking about a main effect, you're only talking about one factor. You're comparing the levels of just one factor only. When you're talking about an interaction, you will always be talking about at least two different factors. And that's why interactions are complex, because they're kind of looking at the interaction or the effects of two factors simultaneously. I do want to look at these chats we have here real quick. Okay, yeah. So let's go ahead. I think this is an example meant to kind of illustrate, especially the idea of main effect. And then I'll have some examples coming up that I think will help demonstrate what an interaction is. And once they're concrete, it's just easier to understand. Once you see graphs, once you see numbers, it just becomes a little bit easier, at least in my opinion. Okay, so here is an example of a 3x2 factorial design. So remember, 3x2 means that there's two factors. The first factor has 3 levels. The second factor has 2 levels. And I said earlier, a main effect, there's as many main effects calculated as you have factors. And so if we have 1, 2 factors, that means we're going to have 2 main effects, which our statistical software will calculate. And each one of those main effects could either be significant or not significant. The different main effects are independent of each other. And so one of these factors, if we can look at the factors, the 2 factors here, we have cups of coffee, and I call it here amount of cups. The levels are 0, 1, and 2 cups. You can see it again over here, 0, 1, and 2 cups. So that's factor 1, amount of cups of coffee composed of 3 levels. The other factor is type of diagnosis, or just diagnosis, which is composed of 2 levels, people with schizophrenia and people that do not have schizophrenia. And so I am giving the answers for the main effect of cups of coffee right here. So these are the 3 means that are compared. Giving these numbers right here, these numbers in here are the short-term memory scores. For people that are classified in each of these conditions, these are people who have schizophrenia that drank 0 cups of coffee. These are their short-term memory scores. People with schizophrenia that drank 1 cup of coffee, these are their short-term memory scores, so on and so forth. We have 6 different conditions, and the means of those 6 different conditions are all shown right here. But for a main effect, I'll remind you, a main effect is only looking at the means of one factor. It's only looking at the means of the different conditions of one factor, and it's completely ignoring the other factor. So when we're talking about the main effect of amount of cups of coffee, we don't care at all whether people have schizophrenia or not. And that's how these numbers, 4.5, 5.5, 6.5, that's how these numbers are derived. This number right here, 4.5, this is the average score of people that drank 0 cups of coffee, combining across all of the scores of people that have schizophrenia and people that didn't have schizophrenia. And so if you take these numbers right here, these are 10 numbers, plus these 10 numbers right here, I believe it's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 20 total numbers. So if you add up these 10 numbers, these are all people with 0 cups of coffee, plus these 10 numbers, these are people with 0 cups of coffee. That's 20 total numbers. Add them up, divide by 20, you get 4.5 right there. Please note, a shortcut way of doing this is just 4 plus 5 divided by 2 also equals 4.5. So the mean of this condition plus the mean of this condition divided by 2 is also 4. There's the kind of 2 ways of getting at this answer right here, 4.5. 5.5, this is the mean score of people in the 1 cups of coffee condition. And once again, we don't care whether these people have schizophrenia or no schizophrenia. We're collapsing across those 2 different conditions. All we care about is these numbers right here, these 10 numbers in the 1 cups, plus the 10 numbers right here. That's 20 total scores. Add up those 20 scores, divide by 20. And then we get the mean, which is 5.5. I have something in the chat. Let's see what's going on here. Yes. So the question is, so those means are just dealing with the amount of coffee. The diagnosis doesn't matter. Very good way of putting it. That is true. Yeah. We just care about people that drank 1 cup of coffee. And we don't care whether they have schizophrenia or whether they don't have schizophrenia. We don't care about the diagnosis at all. We just care how much coffee. And that's what this number is. 5.5 is the average short-term memory score of people that drink 1 cup of coffee, and you don't care about their diagnosis at all. Finally, 6.5 is just the 2 cups of coffee condition. You take these 10 scores in the 2 cups, these 10 scores also in the 2 cups. You add all those 20 scores together, divide by 20, and you get 6.5. Another way of getting this, once again, you can just take the mean of this condition, 4, plus the mean of this condition right here. That's 9. 13 divided by 2 also equals 6.5. So right here, I want you guys to think about this one a little bit. So I'll have someone put it in the chat here as the answer. So now I want us to calculate the means for the main effective diagnosis. So the clue is that there's 2 of them. And we know that the factor diagnosis only has 2 levels, people with schizophrenia, people without schizophrenia. And what we want to do is we want to find out what those 2 marginal means. Remember, these 3 things, these are marginal means. The means that are compared for a main effect are marginal means. These are the marginal means for the main effective amount of cups of coffee. The marginal means for main effective diagnosis will be right here. There's only 2 of them. Basically, what we want right here, this is the mean short-term memory score of people with schizophrenia, and we don't care how much coffee they drank. We only care about what is the mean score of all the people in the study that had schizophrenia, and then what is the mean score of all the people right here. These are the people that did not have schizophrenia. So we have a bunch of answers. Let's take a look. Yeah, good. Excellent. Most people are getting that the answer is 4 and 7, which is exactly right. Yeah, good. Yeah, many answers are getting 4.4 and 7 is the correct answer. So there's kind of a couple ways of getting that. The simplest way is just, you can see right here that for people with schizophrenia, no matter how much coffee they drink, their mean short-term memory score was just 4. And so 4 plus 4 plus 4 divided by 3 is still just 4. So this number right here would just be 4. Right here, we have people without schizophrenia, and they have 5, 7, and 9. So if you add up those 3 numbers, you get, what is it? Let's say it's 12 plus 9, 21. 21 divided by 3 equals 7 right there. 21 divided by 3. 5 plus 7 plus 9 equals 21. 21 divided by 3 equals 7. Another way of getting those numbers, 4 and 7, which would take longer. Probably no one was doing it this way. You could just add up all 30 of these numbers right here, divide by 30, and that would give you 4. You could add up all 30 of these numbers right here, divide by 30, and that would give you 7. So let's take a look here at this chat. Good. Thank you. Yes. 21 is correct. Yes. So yeah, add up all 3 of these. 21 divided by 3 equals 7. So those are the marginal means for the main effective diagnosis. I'm pretty sure that there'll be a question on test 1 where I give you like a scenario problem like this, and you'd have to determine what the marginal means for that problem are. Moving on. So here is the same data shown as a graph. And I want to illustrate here the interaction. So there's the main effect. We just calculated the marginal means for the main effect of amount of cups of coffee. We also calculated the marginal means for the main effect of a diagnosis. Now I want to look at the interaction. And the interaction involves, you're talking about more than one factor. When you're talking about the main effective amount of cups of coffee, we are only talking about that factor, amount of cups of coffee. We were doing diagnosis, main effect, that we are only talking about the diagnosis. But when we're talking about interaction, we're actually talking about both factors or more than one factor simultaneously. And so there's the way that I'm going to suggest talking about interactions when you're looking at a graph like this is I always break it down into the clusters. Here's cluster number one right here. These three bars are kind of right next to each other. This is cluster number one. And then here is cluster number two. When you're dealing with an interaction, you are always comparing the overall pattern of a cluster, and you're determining, are the patterns of these different clusters different than each other? But all interactions are of this nature. You look at a cluster and you're comparing it to the other cluster right here. And so I usually use these little names in my head, like right here, this is like a flat line. The pattern here is it's flat. And the question is, once you kind of see that, it's a flat line cluster right here, then you're comparing it to this cluster over here, which is definitely not a flat line. This one's like going up. And so the interaction, this is a strong interaction, is because the pattern here, a flat line, is different than the pattern here, which is ascending or going up. So this is probably a different way of looking at interactions than you were taught at methods. Oftentimes in methods class, they talk about like intersecting lines when you're dealing with interactions, which is fine, but it's kind of helpful to have more than one technique for looking at these things. At least cognitively, that should be helpful. So the pattern here is different than the pattern here. Therefore, we have an interaction. Another way of thinking about this, which is also helpful, is to ask yourself, how does drinking coffee differentially influence people that have schizophrenia compared to people that do not have schizophrenia? And then my answer to that would be, if you have schizophrenia, the more coffee you drink, it doesn't really do anything. You drink a bunch of coffee and you have schizophrenia, it does not help your short-term memory score. So coffee does not influence the short-term memory score of people with schizophrenia. There's no effect here of cups of coffee for these people. And you can see that because there's a flat line. But if you're talking about people that don't have schizophrenia, the more cups of coffee you drink, the better your short-term memory score. And so cups of coffee has different effects on people with schizophrenia than no schizophrenia. Notice how I'm talking about both factors here. I'm talking about cups of coffee and how it influences people with schizophrenia. There is no influence. I'm also talking about cups of coffee and how it influences people with no schizophrenia. There is a strong influence where, such as the more coffee you drink, the higher your short-term memory scores. So let's just go back to this definition of interaction real quick. It indicates that the difference among conditioned means for one factor is influenced by the levels of the other factor. I always think after seeing these concrete examples, this definition just makes a little bit more sense. These conditioned means right here, the light gray, medium gray, dark gray, light gray, medium gray, dark gray, they're differentially influenced by the levels of the other factor. These three bars are a flatline pattern if you have schizophrenia. These three bars are an ascending or going up pattern if you do not have schizophrenia. I actually want to, so my phone's over here. Check the time. Yeah. I want to actually come back to this stuff. We've talked a lot about research methods. I actually want to get started. We'll finish up. There's just 2 or 3 more slides here, research methods. We'll kind of review some of this stuff next time. But I actually want to talk a little bit about cognitive neuroscience today. So I'm going to switch gears here just a little bit and bring up chapter 1 just a little bit, and then we'll call it a day. Okay, so cognitive neuroscience chapter 1, this is stuff based on a lot more on the textbook now than what we've been dealing with. The the quiz for today was do write a class on chapter 1. And so, yeah, this chapter is mostly about the history of neuroscience. I'd also say it's kind of some of the big picture ideas in cognitive neuroscience. So before we get into some of those like theoretical ideas on cognitive neuroscience, just want to define the term. It is it's taking kind of these two different fields that previously were somewhat independent of each other and then merging them together. So I would say cognitive neuroscience is kind of inherently interdisciplinary because it's kind of merging of fields. Cognitive psychology, let's move this thing. It's kind of a combination of cognitive psychology and neuroscience, which at one point were kind of separate, but this class is merging them together. So the definition of cognitive neuroscience from the textbook is something simple: the study of how the brain enables the mind. That's about as simple of a definition as you're going to get. The study of how the brain enables the mind. I think I have different definitions down here. So we'll get to that. And I thought an interesting thing about this term, cognitive neuroscience, is it's, according to the textbook, it stemmed from a conversation with Gazzaniga, who's the first author of this textbook. So presumably, he's claiming that he helped come up with the name cognitive neuroscience. So he is one of the first cognitive neuroscientists that there are. Gazzaniga, the first author of your textbook, and he did this supposedly in a conversation in a taxi cab with Miller. And so some of you might have heard of Miller's magic number 7 plus or minus 2, which is one of the first estimates of short-term memory from cognitive psychology. Gazzaniga was kind of on the neuroscience side of things for a while. Miller was definitely a cognitive psychologist, and they were supposedly talking with each other in a taxi cab, and that's how they came up with cognitive neuroscience. These two individuals, at least according to Gazzaniga in our textbook, had a conversation, and then they came up with the term cognitive neuroscience. So the definitions from ScienceDaily.com, which is just a website, it's kind of like an encyclopedia of different science fields. They define it as study of neural mechanisms underlying cognition, and it is a branch of neuroscience. That's fine definition. I kind of just think of it as the biology of the mind, biological things that influence or support the mind and behavior. And then here's a definition of neuroscience. It's just neuroscience is definitely the biological aspect of the mind. The neuroscience is the different aspects of the biology. So the structure of the brain and neurons and nerves in the body, their function, the development of those things, things like genetics, biochemistry, in the different aspects of the nervous system. So that's a definition of neuroscience. But really, when I think neuroscience, I just think the biological aspects of stuff. So I want to go a little bit more into the definition of cognitive psychology, because not all of you have maybe taken cognitive psychology. As far as I understand, that is not actually a prerequisite for this class. So you do not necessarily have taken cognitive psychology before. I want to make sure we understand what cognitive psychology is. Cognitive psychology is mental activity, and this is defined from the book. Mental activity, kind of thinking of the mental activity as like an information processing problem. That definition is kind of helpful. Some important things about this definition: that the mind is inferred from behavior, and I will give a concrete example of this. This is very helpful. The definition, it's kind of helpful. The mind being inferred from behavior, that is definitely true, definitely helpful. Some people think of it, when they think this information processing problem part comes from the fact that cognitive psychology, some of the early theoretical approaches were basically like the mind is kind of like a computer. Therefore, they kind of made these assumptions that the way the mind works is kind of the way computers work. And people know that one of the way computers work is they have zeros and ones represent different types of information in a computer. And those zeros, ones, they are representations in the computer. For instance, one pattern of zeros and ones will represent the letter Q. Another pattern of zeros and ones represents the letter R. So each different parts of information that the computer knows about, each information has its own patterns of zeros and ones, which defines or represents that information. Each letter has a unique pattern of zero ones, which defines or represents that letter. And each letter is considered a type of information. Similarly, with the different like colors that appear on your screen, each one of those has a pattern of zeros and ones, which represents the different colors that can appear on your computer screen. So the computer uses zeros and ones to represent many different types of information. Early ideas on cognitive psychology thought that this is a similar thing, that the mind were kind of like a computer, and so it represents information somehow. And so one of the early ideas was it's kind of like zeros and ones, maybe. And that idea is not as strong today as it was in the past. So there's still this idea of representation, but the idea that it's like zeros and ones, I know I'm not for sure how popular that idea is to this day. But we will talk about the idea of representation. I'll give an example here in a second of a representation of information. So an important thing about these representations in cognitive psychology is that they are manipulated, or they are somehow changed or altered while you are performing some type of task. So the idea is there's information, for instance, out there in the world. And for you to be able to understand that information or to make predictions about that, what's going to happen in the near future, you somehow have to represent in your mind that information. And then if you're going to make a prediction about what's going to happen out there in the world, or if you want to understand what's going on in the world, you have to be able to take that information and to manipulate it, or to make simulations or predictions about how that information will change over time or over space. And I will give an example of that right here. So here is a classic example of cognitive psychology. Where should I put this? The Shepherd rotation task. And it is an example of cognitive psychology. And in this study, people are shown two different shapes, like these two shapes right here. This is trial one. In the task, the participants are asked, they're supposed to look at these two shapes, and they're asked, are these two shapes the same or are they different? So obviously the shapes are always tilted a little bit relative to each other. But if you notice that if you look here, for instance, these two shapes are actually identical. So this one is tilted, but if you stand it straight up, you notice that these two shapes are exactly the same. Same here. These two shapes are actually identical. They're just one is rotated relative to the other. Let's see, how do you have to rotate this one? So you would have to rotate this, the second shape, you'd have to rotate it like that, and then you would see that they're identical. But this third set right here, if you look closely, these are actually two different shapes. These two shapes are not the same. And that you can see the answers are here. C is a different pair, which cannot be brought into congruence by any rotation. So the answer here would be same. The answer here would be same. The answer here would be these are different. So I'm going through these fast because I don't want to waste a lot of time. I do encourage you to look at these and see if you can actually do these. If I'm going too fast, make sure that you can kind of agree with the answers, which are presented down here. So this is the task that people performed in the Shepherd rotation task. Here are the data, though. And so this is one of the early examples of cognitive psychology, this idea that we have representations of information out there in the world and that we can manipulate it. So kind of the question here is, what is the manipulation? And remember, I said that one important aspect of cognitive psychology is that the mind can be inferred. What's going on in the mind, the manipulation of the representations in the mind, can be inferred by looking at people's behavior. And so I'm going to show you, explain these data. This will be the last thing we do today, probably. And we want to think about, what is the mind doing? What does the behavior that the people are showing in this graph, what does this suggest that their mind is doing? And so shown down here on the x-axis, this is angles of rotation in degrees. And so what these numbers mean is that you would always see two shapes. And if those two shapes had an angle of rotation of 0, that means that they were both aligned the exact same way. If the angle of rotation was 60 degrees, that means that they would be aligned, like one would be straight up and the other would be turned like this. If it was 180 degrees, this is gonna be a tough one to do. One shape would be like this, the other one would be like this. That's 180 degrees. So these are the relative angles of the two shapes relative to each other. Here they're the exact same orientation, the exact same angle. Here they're completely opposite. and the various degrees in between them. On the dependent variable, or the y-axis, is the reaction time. So in cognitive psychology, the most probably, I'd say arguably the most common dependent variable in cognitive psychology is time, reaction time in particular. In this study, they were only interested in the reaction time for those trials where the answer is the same. So once again, how long did it take people to produce the same answer here? Here, I would say that that shape was rotated like 90 degrees relative to that one. What is the amount of time it takes the shape people to answer here that they're the same? And I don't want to give an estimate. I can't even tell the angle of rotation for that one. And so the dependent variable, the mean reaction time to say same, and then how long did it take people to do that, to get the correct answer, depend as a function of the amount of rotation here. And then kind of if you can see these little circles right here, these are the means of these different conditions. So I'll point out this factor, angle of rotation, this is a factor that has many different levels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a factor with 10 different conditions, 10 different levels right there. So that's a lot of different conditions. Each of these are the means of those different conditions right there. And what you can see, the pattern here is that the bigger the angle of rotation, the bigger the difference in the angle of rotation between those two shapes, the longer it takes people to give the correct answer. I'll say that again. The bigger the difference in the angle of rotation between the two shapes, the longer it takes people to provide the correct answer. So going back to our definition of cognitive psychology, we said one of the things that I mentioned was the mind can be inferred from behavior. And you're representing something and you can manipulate it. So the thing that's being manipulated here is these representations of shapes. But what is the mind doing? So what is this? I want someone to give me, you can write it in the chat here. What is the mind doing here? The behavior, which I kind of described for you, is the bigger the angle of rotation of the two shapes, the longer it takes people to produce the correct answer of the same. The answer is the same. The researcher said, okay, we know what they're doing in their minds. We know what the participants' minds are doing when they're performing this problem, and it is this. Someone tell me, what are the minds doing here? Let's see what these answered. Yeah. Okay, so we have pattern recognitions and finding what they are used to seeing. Okay, the mind is taking the information to manipulate it. That's fine. Okay, here's a good answer right here. Mentally rotating the shapes to see if they match. And this is actually this is the suggestion that was made by the people that actually did the study. The thing cognitively that was learned in this study was that people must be representing the two shapes. We got shape 1, shape 2, and that they're taking one of those shapes, and when they're asked to perform the problem, they're actually having to rotate one shape in their mind until it matches up with the other one. That's what they're doing in their mind. The shapes are like this. And then you see them and you're asking, are they the same or different? The way you're solving that problem, presumably, is you're taking one of the shapes, you're representing those two shapes. Those are the representations, your mental ideas of these shapes, and you're manipulating it by taking one, and in your mind, you're kind of turning it until they match up. And when they match up, that's when you're like, they are the same. You have to turn them in your head until they match up, and then you can output the correct answer the same. The reason that makes sense is because if the shapes are like this, in your mind, you have to do more turning until they match up, and then they look like this. If the shapes are just like this, it doesn't take very long to turn it in your head till they match up. So the more the shapes, or the more the shapes are rotated, the bigger the difference in the angle of rotation between the two shapes, the longer it takes you to respond, because presumably you're rotating those shapes in your mind, and the more the difference in the angle of rotation of those two shapes, the longer you're having to rotate that object in your mind before they match up and you can output the answer of the same. So that's all I want to do for today. I'll call it a day. I will be posting your Master and his Emissary introduction quizzes right after class, or at least within the next couple hours this afternoon. That will be posted. You'll have a week to do that. As usual, if you have questions or comments, feel free to send me emails. Otherwise, I will see you Wednesday.
Thank you.
Thank you.
Thank you.